Hello again. So this is another example of a D flip-flop. So addition to the previous example, it has an active high synchronous reset. Along with that, it has a reset value mentioned. Earlier it was not mentioned, now it is mentioned as a 34. Like flip-flop must reset to value 34 then 0. And all D flip-flops should be triggered by negative age of a clock. This is a new thing. So we will be moving ahead with our coding like always we do. Always instead of positive clock, we will have a negative clock because explicitly mentioned it is a negative age triggered flip flop. As reset is synchronous, there's no need to add in a sensitivity list. So we have reset. So mention reset value is 34. So it is 8-bit value. So we'll have 8H34 value given after reset value. Now the else condition same as the previous. What are the value of input D will be forwarded to Q. Okay, let's try. As you can see, after every reset it is resetting to 34, and when it's out of reset, what is the value of a D? It is forwarding to Q. So yeah, problem statement correct. Okay, so another variant of a D flip flop is active asynchronous reset, and all should be triggered by a positive clock. Two things change here. We have added asynchronous reset and we have to have a positive edge triggered flip flop. So what we do there is the usual clock, but along with that we will have asynchronous reset also to be added in a sensitivity list, because that is an asynchronous reset. As it is active high reset, so any positive age of a reset need to be added here. So if a reset is there, they haven't mentioned anything about reset value, so we are assuming it is 0. If it is out of reset, so we will assign value of D to the output. Let's say what it results. As you can see, asynchronous reset whenever occurs resets to value 0. If out of reset, what are the value of D is there, it is forwarding to Q on the next positive edge. Here also, if it is reset, value is getting resetted. So what are the problem statement is? We are satisfying that. Okay, so another interesting variant for the D flip flop they have given. So as problem statement says, it is a 16 D flip flop. So value of D is 16-bit. So we have to pass it to the value of Q, but with some modification. Like they have introduced a byte enable signal. So based on this byte enable signal, which values to be passed to Q is decided. For example, when byte enable is 1, only the upper byte of a D will be transferred. When byte enable is 0, the lower byte of a D0 will be transferred. If it both 0, then none of them will be transferred. If both are 1, then all the 16-bit of D will be transferred to Q. So as we understood the problem statement, let's start coding it. So we need to have a byte enable and reset. As reset is synchronous, we don't need to introduce sensitivity list. So here reset end, it is active low reset, it is same. So instead of having positive age detection, we have to have a negation of a condition. Whenever there is a negation of reset, whenever reset is low, then our reset condition will be satisfied, and we have to check what is the value of key. It is not mentioned anything about what is the value of Q on reset, so we are assuming it is 0. And for the else condition, now in else condition we need to take care about the byte enable. So when the byte enable is 0, 0, 0, 1, 1, 0 and 1, 1, what are the values of Q? So for that there are two ways. One will be to have a if else condition. The second way to have a case statement. Let's try both. Let's try the case statement first. So case statements, we have byte enable. If we start at case, we should enter case. Now we'll go through the one cases at a time. Let's say we have byte enable first higher MSB is 1, other is 0, then what will be the condition? When byte enable 1 is 1, then only upper byte of D15 to 8 will be transferred. So Q15 to 8 will be assigned by D15 to 8. For other condition 0, 1, similar way, Q7 down to 0 will be transferred to Q7 down to 0. Third condition, if both are 0, if both are 1, then what is the value of Q will be transferred to D, and the default will be Q equal to 0. Let's see how it works out. So we don't need begin and end here. So we have covered two cases which were explained above. The problem statement that if first bit is 1, then up higher bytes are transferred. If lower bit is 1, then lower bit are transferred. Okay, so we have seen some mismatches. Where is the mismatch? Where mismatch is happening here? We have mentioned 0, byte enable is 0. When byte enable is 0, it will retain that value. That is an issue here. And when the byte enable is 0, that is again issue. So we had explicitly considered that when byte enable both 0, what will the issue? So we shouldn't do that. So we'll keep the Q as it is, as a loop back. see, we have a success here.